Alright, so this is on section 6.5, which is on large sample tests for the difference between two means. So let's first by recalling, according to the central limit theorem, that x bar has the normal distribution with mean being mu x and variance being sigma x squared over nx. The same thing goes for y. For the central limit theorem to work, we need a sample size to be large enough, which means nx and ny has to be greater than 30. Then their differences also has the normal distribution. The mean is the difference of original means, and the variance is the sum of the original variances. And we know, often we don't know the values of the population standard deviation, so we use the sample standard deviation instead. Alright, so we can use this to do an example for hypothesis tests. So let's measure the lifespan of a certain virus on different surfaces. So let's test how long the virus will live on metal surface and on plastic surface. So on metal surface, 40 samples were collected. On average, the virus lasts for 5 hours, and then with sample standard deviation being 2 hours. And for plastic, we collected 50 samples, and on average, the virus lasts for 4 hours, with sample standard deviation being 1 hour. So we notice that the difference between the sample mean is 1 hour. So we can consider the following hypothesis test. So what if we want to show that the difference of population mean is at least 0.4 hours. So this is what we want to prove. So H naught, the null hypothesis, will be the opposite, which is the one we want to reject. 0.4. So first we draw the null distribution. So the null distribution has mean 0.4 that comes from the null hypothesis, and the variance is this huge quantity we saw before. And all the values we need are here, 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 and here. So if we plug this in, we found out that the standard deviation is 0.3464. So in a null distribution, where the mean is 0.4, and x bar minus y bar is here, which is 1. So the p-value, which is the area of the tail here, to find the p-value, we need to first find the z-score of this number. So the z is equal to 1 minus the mean divided by the standard deviation, which is equal to 1.732. So once we found the z-score, we can use the table to find the p-value of the test. So the p-value of the test is equal to 0.0418, which is less than 0.05. So because the p-value is less than 0.05, we can reject H naught at 5% level. And that means we accept H1. So we can make the conclusion that the virus lasts at least 0.4 hours more on metal surface than on plastic surface. And of course, this is on average. Okay, so let's do a different example. So let's the same thing. We use the lifespan of the virus, but now we test in different climates. So we test the lifespan of the virus in the colder climate and in a warmer climate. So in the colder climate, 60 samples were collected, and the sample mean is 4.5 hours, with sample standard deviation being 1 hour. And in a warmer climate, 50 samples were collected, and the sample mean is 4.0 hours, and the sample standard deviation is 1.5 hour. So we notice that the difference of population mean is 0.5. So we can consider the following two-sided hypothesis test. So we want to prove that the virus lasts for different time depending on the climate. So we want to prove that mu x and mu y are not the same. And the null hypothesis is the opposite. So null hypothesis claims that mu x minus mu y is equal to 0. So now we can draw our null distribution. So the null distribution has mean 0 from the null hypothesis, and the variance is still this quantity. And if you plug into the calculator, we will find out that the standard deviation is 0.2483. So the null distribution has mean 0, and x bar minus y bar is 0.5. So let's first find the z-score of this number. So the z-score of this number is 0.5 minus the mean divided by the standard deviation, which is equal to 2.01. But because this is a two-sided test, so the p-score, the p-value is the area of this tail and the area of the other side, tail on the other side. So we also need to calculate the area of the tail on the other side, which is to the left of z equals to negative 2.01. So if you look at the z table, this tail has area equal to 0.0222, and so does this tail. So the p-value is equal to twice of 0.0222, which is equal to 0.0444, which is less than 0.05. So because the p-value is less than 0.05, we can reject H0 at 5% level, and we can accept H1. So the conclusion we can make is that H1 is correct, which means that how long the virus lives depends on the climate. Alright, so that's it for section 6.5.